So, Professor, a marine biologist argues that transmission. So, we don't have two people here. Normally, we've seen that there would be A and there would be B in method question. That's not always the case, of course. But here, there are two people, just that they're not written like this. There is a biologist. So, assume that the biologist is saying something, and then the professor, right? Now, professor is telling us what the biologist said. So this is basically written inside the professor's complete dialogue itself. That's all. Otherwise, still there are opinions of two people over here, right? So the professor is telling us what the biologist believes. So a marine biologist argues that transmission of sea lice from farm salmon to wild salmon is unlikely in the Broughton Archipelago, British Columbia, citing numerous studies suggesting that salinities less than 30 parts per thousand are unfavorable to sea lice survival. So he says that transmission of something called sea lice, so we would say that maybe some kind of bugs from farm salmon. So here we have the farm salmon and we have the wild salmon. So the farm salmon looks like they carry these bugs. So he's saying that transmission of these bugs from these guys to these guys is unlikely in a certain region of British Columbia, citing numerous studies suggesting, he says this is unlikely. So, this is biologist's opinion, isn't it? So then we have got what the biologist believes. It's his conclusion, his opinion that this transmission is unlikely. Yeah? And then he tells us, citing numerous studies. So he's still talking about the biologist. He says that the biologist argues that this transmission is unlikely, citing, and then he cites what? Numerous studies suggesting that salinities less than 30 parts per thousand are unfavorable to sea lice. So he says that the biologist has given premises. This is his conclusion, right? The transmission is unlikely. What are the premises that he has given? The biologist, he says that there are lots of studies that say that if the salinity is less than 30 parts per thousand, then it is unfavorable for sea lice survival. So then if salinity of the water over here is less than 30 parts per thousand, then the sea lice doesn't survive over there, right? So then the transmission, this salmon will not like send over its lice to the wild salmon, right? Because the lice will not survive in this kind of water. So this is what the biologist says. This is his conclusion and his premises, which are told to us by the professor. Okay. So the biologist concludes that the archipelago's 25 to 30 parts per thousand salinity range between March and June, the critical period for wild salmon migration, tends to suppress the sea lice proliferation. So he's saying that because the archipelago is 25 to 30 parts per thousand salinity, that particular area of British Columbia, it has what 25 to 30 parts per thousand of salinity, which is less than, as per the studies, what is good for the lice. So that is why, and between March and June, so this is what the salinity is between, let's say, March and June, and that is the time when when the critical period for wild salmon migration. So that is the time when actually the wild salmon are going to migrate. So then this tends to suppress the at that time the sea lice proliferation is going to be suppressed. So because the salinity of the water over there is less than what is appropriate for sea lice, so that is why they will not be transferred. This is the complete argument of the biologist. This is exactly what he says, right? And the professor has told us that. All right. Now, this belongs to what the biologist says. Now, but a review of the literature shows that now the professor is talking. Now, this is what the professor is saying. We are getting now his opinion and his premises, his conclusion. But a review of the literature shows that salinities of 25 to 30 parts per thousand in combination with British Columbia's cool spring temperatures favor the flourishing of sea lice. So he says that, but there is literature, so the review of literature, which tells us that this salinity of 25 to 30. He's saying that yes, of course, it is 25 to 30 ppt. But at this time, in from March to June, cool spring temperatures in that area, they will favor the flourishing of sea lice. So he's saying, but there is literature which shows that these salinities at this time are going to favor the sea lice, right? So in this passage, the professor attempts to undermine the biologist's argument by now. Even before now, we jump to the options. Let's just quickly discuss. So how has he undermined the biologist's argument? He says that the biologist quotes us studies and which suggests that anything less than 30 ppt is not good for these lice, and that in this area salinity is 25 to 30 ppt and between March and June. So then he says that, so then at that time the sea lice will not survive, so they'll not be transmitted. Whereas he says that at 25 to 30 parts per thousand, the salinity in that area and the cool spring temperatures are actually good for the sea lice, right? So the biologist had given us a premise that this is the salinity at this time, this will not be good for the sea lice. So then the transmission is unlikely. That was his conclusion, and these were his premises. Here he says that this salinity at this time is actually, there is literature that shows that it is actually good for sea lice, for flourishing of, it favors the flourishing of sea lice, right? So basically, he's saying that, hey, you know what, your premises don't really hold. Now, look, and sometimes, learners get confused over here. When we are reading an argument, we have to take the premises to be true. I agree. Yeah. But when two people are talking, now we have to be rational. We have to say that, okay, the data given to us is not incorrect. Because, look, in case we were to question that, then, we would have to know so much, right? We won't know whether the data is incorrect or not. So we always have to take the data to be correct. This is how an argument is made. But when there are two people talking, when one is quoting the other, or when professor is talking about the biologist, he doesn't have any such constraints, right? In his argument, he can say, hey, you're quoting wrong data. Hey, you don't know about it. Hey, this is not true, right? So, in the dialogue, in your method questions, one person can certainly raise doubt on the premise of another person. That is absolutely fine. He can do it. And when he does it, we have to say that he's undermining the other person's argument by raising a doubt about his premise. That is absolutely okay. When it comes to a weakened question, for example, we cannot do that. Right? When the author has given his argument, his facts have to be taken to be true by us. But because we have to be reasonable. But then when two people are talking, one could be unreasonable, it's okay. Or, it maybe they're not even, the first could have been unreasonable. Maybe he did not quote the fact correctly. We don't know, right? So don't get confused here. When given in an argument between two people, one person can cast doubt on another's premises as well, which is pretty much what he does for you. Right? Okay, so let's look at the options. So how does he undermine? He attempts to undermine, right? Again, I mean, attempts to undermine. Do you see that? They don't say how does he undermine, because, we don't know. Now, there are two conflicting so-called facts. We don't know what is correct. So he's making an attempt over here. Okay. A, pointing out that a condition claimed to be necessary for sea lice survival is not sufficient for it. Look, we are not talking about necessary conditions over here. We're not saying, he says necessary would be that, this is required. He has not suggested that. He says that salinities less than 30 parts per thousand are unfavorable. That doesn't mean that, they'll certainly not survive, isn't it? The whole argument is based on what is likely, what is not likely, etc. So here we're not really talking about necessary or sufficient conditions at all, right? And he doesn't point out that a salinity of less than 30 parts per thousand is sufficient for the sea lice to survive. No, he's not saying that either. Right? So this is not correct. Look at B. Citing studies that suggest that salinity levels were not measured reliably. Now, does he say that they're not? No, they're both agreeing that the salinity levels are about 25 to 30 parts. So then again, this is not correct. C. Claiming that there is evidence showing that one of its premises is false. Now, this is how the professor attempts to undermine the biologist's argument. Biologist says that this salinity at this time is not good for sea lice, whereas he says that there is evidence showing, he's claiming that there is evidence showing that one of the premises, that is that this salinity in this time is actually good for the sea lice, right? So he's saying that one of the premises is false. So looks good. D. Questioning the reliability of the biologist's scientific sources. Now, this is one, option that confuses maximum people, but do understand that this is not correct. What would be, how would someone question the reliability of a source? He would say that, if you're talking about, let's say, he's given over here, right, that studies, he's citing numerous studies over here suggesting so and so. So in case we were to question the reliability of a study, what would we say? That, hey, the sample size was very small, you know what, there were the study was biased because it was conducted by so and so, etc., right? That is how you question the reliability of a scientific source of a study. Now, the study only suggests that salinity is less than this is not good, right? So you cannot question the reliability of the study of the source by questioning the conclusion. That's not how it goes, right? Studies are conducted to arrive to suggest conclusions. You can question the conclusion even if the study is reliable. Right? They would have done everything right. This is what it looks like. It may not still be true. It is something that the study could suggest. It may still not be true. Okay? To question the reliability of the source, you would have to say that it was not conducted properly. There were biases, or if people had some ulterior motives or something like that. Okay? So then this is not the correct answer. And then E is showing that its conclusion is inconsistent with its premises. Does the professor say that the biologist's conclusion that transmission is unlikely is inconsistent with the premises? No. It makes perfect sense, right? The biologist's conclusion is as per the biologist's premises. He says that the studies show that in less than 10 ppt, the sea lice don't really flourish. And then he says that it is 25 to 30 ppt. So then he says that transmission is unlikely because the sea lice won't really flourish. Right? So biologist's conclusion is absolutely fine as far as his premises are concerned. So he does not show that it is inconsistent with the premises. Right? So again, this is also then incorrect, and our correct answer is C over here. And this is a slightly tricky question. I hope you understood it.